In this example, we are considering what we call counterexamples. These are graphs of functions that do not meet the hypothesis of Rolle's theorem. Therefore, we are not guaranteed to have the derivative at some point C in the open interval from A to B to have the derivative equals 0. In other words, we're not going to be able to find or guarantee to find a horizontal tangent. Now, once again, the conditions on Rolle's theorem, they say that the function has to be continuous on the closed interval from A to B and differentiable on the open interval from A to B. And f of A has to be equal to f of B. Okay, now in the first example, A, you'll see that the y partner to A, f of A, is equal to 0 because it's sitting on the x-axis. Same for the y partner to B. F of B is also equal to 0. So we have equality of the y partners. F of A is equal to f of B. They're both equal to 0 in that example. The problem here is that we have a discontinuity. The function is not continuous. Recall, we have to have it continuous on the closed interval from A to B. But this function takes a big jump, and there's a big hole, and you have to go all the way down to this dot on A on the x-axis to find that point at A. So it does not meet the criterion on Rolle's theorem that says continuity is required on the closed interval from A to B. We have a discontinuity here, so it's not continuous at the point x equals A, which is one of the endpoints. Okay, so you can also just look at this graph and see there's no way you're going to take a point on the open interval, an x value between A and B, and find its y partner on the graph and be able to draw a horizontal tangent at any point between A and B. So just as we said, there's no guarantee you'll have a horizontal tangent here because Rolle's criterion is not met. Similarly, for part B, we have a discontinuity. This time, instead of on an endpoint like we did in the last example, we have the discontinuity on an interior point on the closed interval from A to B, some value x. Here we have a jump discontinuity again at that point. And if we have a discontinuity, it doesn't fulfill the requirement, the hypothesis on Rolle's theorem that says you have to be continuous everywhere from A to B, including the endpoints. And you can look at this example and see that there's no way we're ever going to be able to get a horizontal tangent on any value x corresponding to a point on the graph between A and B. Sure enough, we were not guaranteed it would happen because we didn't meet the criterion of Rolle's theorem. And lastly, item C, here we have continuity. If you were a little ant crawling on this graph, you wouldn't fall through any holes or fall off any cliffs. You had the sticky feet, so you could actually climb all the way up to that cusp, that abrupt turn, and come back down. But remember, when x is equal to a value where the graph takes an abrupt turn, we have non-differentiability at that sharp turn or that cusp. And that's why, if you recall back in the beginning of the class, we said that to be differential at a point is related to the limit of the quotient function, but it's also related to the slope of the tangent line. And you can see as you approach the point x from the left, you get a tangent that leans to the right, so it has a positive slope. But if you approach x from the right, then you have the leaning on towards the left, which means you have a negative slope. You don't have agreement with the limits or the derivatives. So therefore, it's non-differentiable at that cusp, at that sharp turn, where we have the value x corresponding to that point. Now, Rolle's theorem, note number 71, requires that we be differentiable on all of the interior points, open interval from A to B. But here we have a value x between A and B where we are not continuous and we're not differentiable because of the cusp. And sure enough, it's impossible to imagine a point anywhere on this particular graph where you would have a flat horizontal tangent. In other words, you would have the conclusion of Rolle's theorem, which says that the derivative at that point would be 0. So in these three examples, we showed that we had failure on that guarantee of Rolle's theorem, which says that you'd have a horizontal tangent. We have failure because in each of those three cases, we did not meet the three requirements for Rolle's theorem. So go back to note 71 and meditate on those three requirements: continuity on the closed interval, differentiability on the open interval, and equality of f of a and f of b.